Hello everybody and welcome back to this introductory course on machine learning. You've made it through Unit 1 and Unit 2 and now it's time for Unit 3 on unsupervised learning. This is the first video of Unit 3 and it's simply going to cover an introduction to unsupervised learning, kind of lay the foundation for going into more detail and different methods later. But for now, let's take a quick look at the unit overview so we can understand what we are going to be doing over the course of the next few videos. Alright, so this is just video 1 and it's going to be a quick introduction to unsupervised learning. This entire unit is actually going to be a little bit quicker than especially Unit 2, which was on supervised learning, simply because unsupervised learning is less common and has less stuff to cover than supervised learning. So, video 1, quick introduction. Video 2 is going to cover association rules, and with that, market basket analysis, and we'll talk about what that means. Video 3 is on clustering methods, different clustering algorithms, especially k-means clustering. That's the most popular method of cluster analysis. And then video 4 actually isn't on unsupervised learning. This is going to be on reinforcement learning, which is really a third alternative to supervised and unsupervised learning. So since we aren't going to have our own unit on reinforcement learning, we're going to cover the basics of that in this fourth video because it kind of falls into line with this unsupervised learning. But we'll talk about how that's similar and how that differs in that video, as well as some of the different elements of reinforcement learning. All right, so let's get started with this video, and that is the introduction to unsupervised learning. So what is unsupervised learning? To understand that, we need to compare and contrast it to supervised learning, which we explored in the previous videos. And supervised learning was concerned with predicting the values of one or more outputs or response variables for a given set of input or predictor variables. So the predictions were based on the training sample of previously solved cases, and the joint values of all the variables are known. So this is called supervised learning, or you might hear learning with a teacher. In this video, we'll address the alternative, which is unsupervised learning, or referred to learning without a teacher. And in this case, one has a set of observations of a random vector with a joint probability density, and the goal is to directly infer the properties of this probability density without the help of a supervisor or teacher providing correct answers or degree of error for each observation. So you see this probability formula here. We've got the probability of x and y, which is dependent on the probability of y given that we have x, and simply the probability distribution of x. Supervised learning was concerned primarily with this probability of y given that we have x. In unsupervised learning, we're going to be strictly looking at the probability density for our inputs x, because we don't really have an output y. We only have one set of inputs x, and we want to infer the properties about that output probability density. So again, this is trying to gain knowledge from our data. So what are some of the challenges of unsupervised learning? Well, we often have very high dimensional objects in unsupervised learning. So for example, you could use unsupervised learning to do what's called market basket analysis, which is to look at the different transactions or products being bought by customers at a supermarket. And so the input is going to be every single available item in that supermarket. So some stores, maybe Walmart, are going to have tens of thousands of items. So our inputs here are going to be substantially larger than our previous cases. Another challenge would be that the properties of interest are much more complicated than simple location estimates. So we are trying to extract different features from this output probability distribution, and some of those features can be pretty complicated mathematically, and they're not quite as simple as a prediction or location estimate like we've done with supervised learning in the past. Another challenge is that it's fairly subjective. We don't really have a clear measure of success. When we're trying to do something like cluster analysis and form different clusters of similar data, it's hard to say exactly when we are successful. So the output of these models are often subjective in that they have no clear defined measure of success. But there are some benefits to unsupervised learning. There's no conditional variables. So I mentioned in the first slide that there isn't really an X and Y, there's just X. And X represents all of the variables under consideration. Our inputs aren't dependent on an output. Our output isn't dependent on an input. We're only looking at one input variable and the relationship among itself, and it's not conditional on other variables, so that makes our problem simpler in a lot of cases. Alternatively to that, in unsupervised learning, we don't need labeled data. Remember, we don't have an output that we're expecting, which means all we need is the input information, and that can be collected from, like in this sentence here, it says lab instrument or a computer, and it doesn't require this outside intervention to tell the computer what is actually going on. So we've talked about previous examples such as recognizing handwritten digits. Somebody had to go through and look at each image and say, all right, this is a 2, this is a 6, this is a 7, so that the computer could then learn from those positive and negative examples. In unsupervised learning, we don't need to do that step, and so the data is much more accessible. It's very easy to get unlabeled data. It's much more difficult to get labeled data in industry. So unsupervised learning ends up being used in cases when we don't actually have that labeled data. All right, so what are some common methods of unsupervised learning and what are they used for? Well, the first method would be non-parametric methods, and these are very beneficial for low-dimensional problems. So non-parametric is easiest to understood by covering what parametric means, and parametric means is just that we're assuming that the sample is drawn from some distribution that obeys a known model, for example, like a Gaussian distribution. And so this approach is advantageous because it's defined up to a small number of parameters, such as mean and variance, that are the sufficient statistics of the distribution, and once those parameters are estimated from the sample, the whole distribution is known. So in non-parametric methods, we don't make an assumption of that Gaussian model or an assumption of another type of distribution, and we attempt to solve it without that information going in. There's also the alternative, and this is really the parametric methods, and this is the global methods such as Gaussian mixtures or simple descriptive statistics. So a Gaussian mixture is actually going to be a multiple different groups under Gaussian distributions that can be described individually by Gaussian models. But the global methods, you're going to make some more assumptions, you're going to have more implicit bias than in the non-parametric methods, and sometimes that bias can be a means of error. So it's not always good to assume that the data is going to fit these global models such as Gaussian distributions, because we don't always know that for sure with our input data. Another one is cluster analysis, and this is actually going to be the subject of video 3. So cluster analysis is simply trying to group objects or input data into similar clusters. And so in cluster analysis, we're going to talk about similarity and dissimilarity and how we define that in a lot of different scenarios. Cluster analysis is actually going to be probably one of the most common unsupervised learning methods. Also with that, we have association rules, and this is going to be the topic of video 2. Association rules are looking for dependencies amongst different variables. And again, this is going to be used in market basket analysis, where we're looking at the transactions in a supermarket, let's say, and trying to come up with conclusions like, if a customer buys this product X, they're also going to like this product Y. And based on that information, we can change our marketing schemes or advertisements to reflect those associations. So these are some of the common methods. We're going to cover cluster analysis and association rules in more detail. Non-parametric methods and global methods we're going to mention and then kind of leave aside simply because we don't have time to dive into all of these different topics in depth in this introductory course. But it's still good to know that they are available and out there because they are beneficial in some scenarios, like the non-parametric methods in low-dimensional problems. However, when we start to get thousands or tens of thousands of dimensions based on simply on the number of inputs that we have, that is when we're going to be using things like cluster analysis and association rules, which we will talk about more in the later videos. All right, so we mentioned the measures of success in unsupervised learning. In unsupervised learning, we don't really have a clear measure of success. It's very subjective. In the supervised learning videos, we talked about clearly defined metrics such as expected loss, empirical error. We mentioned the residual sum of squares. These things can all be used to lead our model in the right direction and teach it what we want it to learn. However, in unsupervised learning, there isn't that clear direct measure of success. We'll talk about later in k-means clustering how we can use something such as Euclidean distance to produce a measure of similarity or dissimilarity. However, that is going to vary depending on the methods that we employ. So it's important to keep in mind that unsupervised learning doesn't have a clear measure of success. However, it is going to be very beneficial if we're trying to extract features or knowledge about our input data and learn about the output probability distribution or just the probability distribution of the data that we have and extract that distribution so that we can use it for future analysis. So this is an introduction to unsupervised learning. We're going to dive deeper into cluster analysis and in the next video, association rules, so we can see how we're actually going to employ this type of machine learning. Thanks for listening.